Hello viewers, in this tutorial we'll be looking at uh, how to sketch the graph of f inverse given the graph of f. Now we have three questions here. This is the first one, is that we have f of x to be this. We want to sketch the graph of f inverse. The second one is f of x is x squared minus 2x. X is greater than or equals to 1. We want to sketch the graph of f inverse. Then finally the third one is saying that if f of x is x squared plus 2x plus 4 and x is greater or equals to minus 1, find the interval where the graph of f inverse is completely above the x-axis. So please stay tuned up to this number 3. Very interesting questions. So let's start from number 1. Now, number 1, let's first of all sketch the graph of f. Now, this is the graph of f. This is a root function, so this is 0. Let's say this is our y-axis and this is our x-axis. Now we just need to know what will be the x-intercept by taking the inside, what is inside the roots, equate it to 0, we'll have minus half. So it means we have this point. So we have something like this. So here is going to be minus half. So it means we have a point here. Which point is this? This is minus half 0, right? And also here we can see we have a point here, which is just the y-intercept. And when we put x equals to 0 here, we're going to have what? So this is the point 0, 1. Now we're going to be using two things to draw the graph of f inverse. The first one is that what? We know that the graph of what? F and the graph of f inverse, they are what? They are symmetric along which line y equals to x. Y also, if you have a point xy on the graph of f, this is equivalent to saying that yx, the point yx, is on the graph of what? F inverse. So these are the two tools that we need. So now let's get what is the line y equals to x. So the line y equals to x is just a what? A straight line that passes through the what? The origin. So this is our line y equals to x. And this is what? This is the original function, which is f. Original function, it's f. Okay. Now, what we can do here is now we can see that we already have some points here. So since we have points, this point is minus half 0. If you this is on the graph of f. On the graph of f inverse, it will become 0 minus half. So it's somewhere here. So somewhere here. So this is minus half. So this is the point minus 0 minus half. And now this point here, which is 0, 1, this one will become 1, 0. So somewhere here. So this is 1, and this is the point 1, 0. Now we have another point here. As you can see, there is a point here, even on the blue line, because the blue line, which is the original line, the original curve, you see it intersects the line y equals to x. So even when you reflect this point across this line, it will still remain the same point. So we can still put it to be also purple. So both the purple and the blue color will meet at that point. So we're going to have just something like this. We can take more points, but I think these are enough. And this will keep going as well. So this is the graph of what? Of f inverse. Okay, so if you want to know the exact point here, all you need to do is to take, you equate this and y and x and solve for x, but we don't really need to do that. Now, number 2, Number two is this one. Also here, we will need to graph the original function. Now, to graph the original function, we have two options. It's either we use completing the square or we just find the vertex directly. For example, this is a parabola. So we can find h, which is just minus b over what? 2a. We can take a to be 1 and b to be what? Minus 2. And so this will become 2 over 2 times 1. So this is just 1. Then k is going to be f of 1. And if you put f of 1, this would be 1 minus 2, which is just minus 1. So we know that the vertex is just hk, which is 1 and what? Minus 1. Now we know that this is an open. So let's see. We know that this is going to be open up because the coefficient of x squared is positive. So the vertex is at 1 and minus 1. So 1 and minus 1, let's say this is 1, and let's say this is minus 1, and this is 1. So we're going to have something like this. What is the y-intercept? If x is 0, so it definitely is going to pass through the origin, because that is where we have the y-intercept, right? So it's a curve. Now, but we have a condition, and the condition is that x is greater than 1. So it means actually we are not interested in the left-hand part, so we can remove this side and just maintain the right-hand side. That is where we have this one, right? So something like this. So this is the original graph, the graph of f. Now we need to the graph of f inverse. But before that, we now need to draw our line, which is the horizontal, the line y equals to x is a line that passes through the origin. It will keep going, and at some point, it's going to cross these as well. Okay, so let's see how to get our point so that we can, don't forget here, there is a something like this, right? Okay, now what do we know? We have a point here, so we need to translate this point. This point, don't forget, this is our vertex. This is the point 1 and minus 1. Then let's get more points. Why not? Here we can have this point. Which point is this? If you look at this point, this point is the x-intercept. So it's an x-intercept which we can easily find. We can find the x-intercept by putting the original equation into 0. For example, this is x squared minus 2x equals to 0. It means x minus 2 equals to what? 0. So this graph, the original graph, will actually cut at x equals to 0 and x equals to 2. So no doubt, this point is just 2. So it means that we have a point here, 2 and what? 0, right? And as you can see, we can have a point here. You see this point? We can know which point is this. If we want to calculate the exact point, we can go ahead to calculate it if you want to know. Now, how do you do that? It's just the line where the curve and the line meets. And we can do that here. We can do that here and say, okay, where is x squared minus 2x equals to x, right? So it means you're going to have x squared minus, is going to be minus 3x now equals to what? Equals to 0. So this would be x minus 3, right? Equals to what? 0. So it means at x equals to what? X equals to 0, and at x equals to what? and at x equals to 3. Okay. All right. So let's see. Minus 2 to a. Okay. F1. Yeah. So it means it's going to be at the point somehow, I think, at 3. That should be at 3 then. Yeah. So this point is not going to be, this point is just going to be 3 here. So this point is 3. And if x is 3, we can know what is what? What is y? If you put 3 here, y is equals to, uh, so put 3 here, you are going to have 9 minus, so 9 minus 6, which is also going to be at 3. So this point is somehow 3 and what? And 3. So, yep. Okay. Now it is 3 and 3, as you can see. It is 3 and 3. Okay. Now, I hope it is clear. So, what do we do? Let's use now, get now our inverse. Now, this point is what? This point is 1 and minus 1. So, since this is 1 and minus 1, it's going to become what? It's going to become minus 1. I'm dealing with this point now. It becomes minus 1 and 1. So, somewhere here, let's put it here. So, it means here is 1. Is that okay? All right. So, now we also have this point, which is what? 2 and 0. So 2 and 0 is going to become what? 0 and 2. So 0 and 2 somewhere here. So this is going to be 2. So this is point 0, 2. Okay. Then finally, this point, which is 3, 3. You see, 3, 3. If you take the words, if you interchange it, it's still going to be 3, 3. So it means you still have the point. The purple point is still going to be here. So this simply means that you are going to have something like this one, like this. So this is going to be our line, but definitely it's not going to just stay here. It's going to cross and keep going as well. So the purple one is the graph of what? F inverse. Okay, so, and as you can see, there's the symmetry is there. The distance from here is almost the same thing as the distance from here. So the line y equals to x divided into 2 equal part. All right, so let's go for the last question. The last question is saying that if f of x equals to x squared plus 2x plus 4, where x is greater equals to minus 1, find the interval where the graph of f lies completely above the what? The x-axis. So here we're going to do it in 2 ways, so please stay tuned. Now, what's the first method? The first method is to graph this function. Just graph the function, just like we did now. And to graph this function, surely we need the vertex. So what will be the h? Is minus b over 2a. So a is 1, b is 2, and c is what? Is 4. So this is going to be, so we have minus 2 over 2 times 1. So this is going to be minus 1. Then k is going to be f of minus 1. F of minus 1 is going to be 1 minus 2 plus 4, which is equals to 3. So the vertex is nothing but minus 1 and 3. Okay, now let's sketch this graph. Let's do it here. So minus 1 and 3. So minus 1 somewhere here. and positive 3. Let's keep it here. Let's go down a little. I need more space. Minus 1 and 3. And this is going to be still open up. Uh, Something like this. It's not uniform. Okay, let me extend this a little wider. Yep. So let's say this is 3. Now, this graph, does it have a y-intercept? Of course, when x is equals to 0, here is going to be 4, right? Now, but we have a condition. What is the condition? That x is greater equals to minus 1. So it means we are interested only in the positive side, the side greater than minus 1. So it means we're interested in this part, like this. Okay, so this is the graph of f. Now, let's see. Here we have a point already. We have a point minus 1, 3. And here you also have a point. And what is that point? That point is just 0 and what's and 4. So now let's see how the graph of f inverse will look like. Where is the line? We need the line y equals to x. So the line y equals to x will be a straight line through the origin. So this is the line y equals to x. So let's see. Now let's transform the point now. So this is minus 1, 3. It will become 3 and what? Minus 1. So it's going to become 3. Say this is 3. And let's say minus 1. So it will become this part. So this will be this point. And this point is what? Is 3 and minus 1. Okay. Then we have this point, which is 0 and 4. 0 and 4 will become 4, 0. Remember here is 3. So 4, 0 will be somewhere here. So it will be on this line. So because this is 4, 0. Let's extend this a little here. All right. Okay, so now we have an idea of what the graph will look like. This is just going to cut this line. So this will cut this way. It will cut here. And definitely it will keep going. It will keep going here. So this is the rough sketch of the graph of what f inverse. So here is not that perfect, but it gives us an idea. The symmetry, the distance from here is supposed to be the distance from here also. Now, this is the graph of f inverse. But the question is asking us what? The question is asking us find the interval where f inverse lies completely above the x-axis. And if you can see, remember at 4, 0, it's on the x-axis here. And here, you see, it continues this way. So it means that the interval is going to be from where? From 4 open, from 4 close up. Okay, completely above. So it means we're not saying on the interval. So it's just going to be from 4 to where? To infinity. So you see that what? F inverse lies above x-axis on the interval 4 to where? 4 to infinity. So because any number you take here now, you're going to be on above the x-axis. If it says on the x-axis, then it's just at this point, right? Now, this is using graphical method. Now, let's assume you don't like this one. There is another way we can do it without even graphing. So let's do it. Let's do it now. Let's do this same question without graphing. So we don't want to graph. We can just go directly and look for the inverse. Remember, this is the function x squared plus what? 2x plus 4. And we have x is greater than minus 1. So let's get the inverse. Y is what? X squared plus 2x plus 4, right? X greater than equals to minus 1. How do we find inverse? You interchange. So you have y squared plus 2y plus 4. Then you have to interchange the condition also. Now we have to use completing the square. This is y squared plus 2y plus 1 minus 1 plus 4, right? Just completing the square, half of the coefficient of 2. So these terms will give us y plus 1 square. Then you have minus 1 plus 4. Minus 1 plus 4 is going to be plus what? Plus 3, right? Then this is x minus 3. It's equals to what? Y plus 1 all what? All square. If you take the square root of both sides, we have x minus 3. And this would be absolute value of what? Y plus 1. But since y is greater than equals to minus 1, it means this is going to be always positive or 0. So we can remove the absolute value. So you have this, and this is y plus 1. So what is y? Y is going to be root of x minus 3, then minus 1. But our y is what? Is f inverse of x. So f inverse of x is this one. But what is the question asking for? It's asking for the interval where completely lies above the x-axis. So it means you are looking for the interval where f inverse of x is greater than what? 0. So all you need to do is to set this your term to be greater than 0. So this is what we got, greater than 0, and solve for x. If it says lies below the x-axis, then set it to be less than 0. So this is going to be root of x minus 3 is greater than 1. Yes. So what does this mean? This simply means that also, if this is happening, then definitely you can also get that what? X minus 3 is greater than 1. So what do we have? We have x is greater than 4, which is just 4 to infinity. Is that okay? Now, there's another way to use to solve this particular method, this particular question. So anytime you are given question and it's not actually asking for the graph, and it's just asking you to find the interval where f inverse lies above or below, you can use this method in green without, or you can as well graph, then try to check the region. Okay, so I hope this tutorial is clear. If you have any question, please put it in the comment section. Thank you for watching.